Alright guys, we're going to work with absolute value functions and piecewise functions today. So this was the graph you should have made for your starter. A graph of f of x equals x, which is the red line, and f of x equals the absolute value of x, which is the blue function that you can see. So let's analyze these functions. Where does f of x remain unchanged when graphing absolute value of f of x? In other words, where are x and absolute value of x the same? And we can see it happens here where these functions overlap. That's where these functions are the same. So let's write this in inequality notation. There are two ways to write it. We have 0 is less than or equal to x is less than infinity, or just x is greater than or equal to 0. Either way, it works. All right, next question. Comparing these graphs, where do the values of x change when graphing absolute value of f of x? In other words, where are these not the same? And we can see it's in this other part of the graph. So let me get another color. So here is f of x equals x, but here is f of x equals absolute value of x. So this is where the values changed when graphing the absolute value. So that, again, there are two ways to write it. Negative infinity is less than x is less than, and we already used an equal 0 up there, so I'm going to take away the equal sign here. Or we could write x is less than 0. All right, so how can we represent this change now? That's what the next question wants to know. Like, we know it's different, but what exactly is different about it? And what happens is we can see that one is a reflection of the other. So there are a couple of ways we can think about it. When we did transformations, how did we represent a reflection? This was with a negative sign. A different way we can think about it is, what does an absolute value do? It makes something that is negative into a positive. So how do we do that? For example, if we had -3, if we absolute value it, we know it equals 3. But what's a different way we can do this without using the absolute value symbol? Well, what we can do is we can add another negative sign. A negative 3. That is also equal to positive 3. So the change was a negative change to a positive. And the way we can do that is use a negative sign to show it. So now the thing is, we can actually write this absolute value function as a piecewise function, splitting it up into where the function changed versus where it didn't change. So absolute value of f of x. There was a change versus not change. So for this one, there are two parts. Absolute value of f of x is the same as f of x in the unchanged part. So where was this? The unchanged part was that first question we answered. So let's use that domain. X is greater than or equal to 0. Versus it changes in the other section. And remember, one way to show that this change happened, that this reflection happened, is with a negative sign. So we have negative f of x when x is less than 0. And let's actually make this applicable to our specific function. We have absolute value of f of x is equal to this function. F of x was equal to x when x is greater than or equal to 0, versus it's negative x when x is less than 0. So again, that is how we can write an absolute value function as a piecewise, by determining where the function stayed the same, which was up here, versus where it was different, which was down here. So let's do another example so you can see some more and get a little bit more clarity about it. All right, not a line anymore, we have a parabola, specifically the graph of x squared minus 6x plus 5. All right, so let's look at, if we were going to make the absolute value, where would this graph stay unchanged? Where would the absolute value not affect this graph? And let's think of this. When does absolute value not affect a number? If we take the absolute value of a number, it's still the same number. That's going to be when the numbers are already positive. For example, the absolute value of 5 is 5. It didn't do anything. And it works the same way for the graph. When this graph is already positive, that is where the absolute value is not going to do anything. So we know if we graph the absolute value, this part and this part will still be the same. And let's write that set of values in inequality notation. So in this case, there are two sections. One is to the left of 1, and the other is to the right of 5. So unchanged is when x is less than or equal to 1, and when x is greater than or equal to 5. Versus, where does this graph change? Well, it's in the remaining section, because this remaining section we can see is negative. That section is negative. So if we take the absolute value, it's going to become positive. So what it's going to do is it's going to flip to the other side, and we'll see something like this. So the red graph is the absolute value of g of x. And let's just do the negated section. That's between 1 and 5. And we already used our equal signs in the other section, so let's not use them here. That's where we have a negation versus remaining unchanged. All right, so let's write a piecewise function for this. So let's see. Absolute value of g of x. Now in this one, we're going to have 3 sections, because remember there were 2 sections here where we had an unchanged value. So 3 sections altogether, because we had 1 change, and that's a horrible looking bracket, and I'm going to erase that. Marginally better. All right. So unchanged, where g of x is, where the absolute value of g of x is still g of x. That's going to be when x is less than or equal to 1, but also at the other end, when x is greater than or equal to 5. But in the middle, we had to flip it around, reflect it, or otherwise known as negating it. So negative g of x, when 1 is less than x is less than 5. So again, we want to write this for our specific function. So the absolute value of g of x is equal to, so we keep it g of x, which was x squared minus 6x plus 5. And that's for x is less than or equal to 1. And I'm going to give you a little shortcut. We can also write the other section here, x is less than or equal to 1, or when x is greater than or equal to 5. Versus the other section, we have to negate the whole thing. So negative, and use parentheses here, negative x squared minus 6x plus 5. We negate it in that middle section when 1 is less than x is less than 5. So to summarize, look for the places where the function stays the same when the absolute value happens, and that's when the function's already positive. Because like we saw in an example, absolute value does not affect a positive number. And you'll write the original function and the domains where it was already positive. Versus where the function was negative, over here, we're going to have to negate a negative to get a positive. So you will write a negative in front of your whole function and use parentheses to in front of the whole function, and then the domain where that function was already negative. All right, if you have any questions, again, make sure you're emailing me or coming online during our period 2 Google Meets. Stay safe.